Thank you for this opportunity. We believe there is greater room for improvement in canned foods PR to PO process as highlighted at the end of our second report. Today, we present two process innovations. One, AI engineering to improve supplier selection efficiency, and two, hyper-automating PP's role and the creating, printing, and faxing of POs. We project key impacts of almost 90% in decrease in activity times, as well as removing unnecessary manpower usage.
Our first process innovation idea is to use AI engineering to improve supplier selection efficiency. Currently, PB calls existing contracted suppliers to negotiate for earlier or urgent deliveries for 30 minutes, BA finds suppliers on the internet or through contacts for 60 minutes, and then calls them to negotiate for 45 minutes. These activities are time-consuming, and our first solution seeks to improve the selection efficiency for suppliers. The solution utilizes AI to efficiently select suitable suppliers by using machine learning to prioritize suitable suppliers in the ISMS or on the internet and call multiple suppliers at once to negotiate. The AI would then update the successful negotiation details in the CMS.
This solution will be enabled using AI engineering strategies such as machine learning analytics, neural networks, and natural language processing capabilities to ensure it is robust enough to handle large amounts of data and sufficiently replace the role of BA. Implementing machine learning analytics, such as the score model into our supplier selector function in the ISMS, helps to evaluate and prioritize suppliers who are more likely to accede to requests by taking into account their past transaction histories. Finding suppliers on the internet would also be performed significantly faster through the use of a web crawler and machine learning techniques like natural language processing and sentiment analysis to source and discover suitable suppliers. By adopting this solution, activity cost and time would be significantly lower when selecting a contracted supplier, sourcing for suppliers on the internet, and contacting suppliers. We also see that the BA would no longer be needed in the workflow as he will be effectively replaced by the AI. However, we do recognize people and technology challenges to this. Firstly, suppliers may be resistant to interacting with an AI. As such, canned foods management would have to take the lead in pushing for digital transformation. Secondly, time and data is required to train the model and the AI. This can be overcome by having a human actor to monitor the AI's decision-making ability by applying a reinforced learning paradigm. Lastly, there's a high IT infrastructure investment and maintenance cost of implementing the AI. Canned foods management will have to prioritize digital transformation as a goal and anticipate risks to ensure the solution is rolled out strategically in a low-risk manner.
Our second solution seeks to replace the PP with hyper-automation and also hyper-automate the creating, printing, and faxing of POs to suppliers. Currently, PB has to verify the PR details and committed budget before endorsing the PR in the CMS. Then, PB receives a notification of the endorsed PR and manually creates, prints, and faxes the PO to the suppliers. This is a relatively time-intensive activity at approximately 24 minutes for each run. This manual process is not value-adding to canned foods and can be further improved. With the new solution, the RPA bots will extract the PR details and committed budget from the CMS. An ML model then verifies and validates the information. The PB will be able to intervene if the ML model flags out a low confidence rate for any particular PR. RPA bots then update the PO details, and if the suppliers are inside canned foods ISMS ecosystem, proceeds to send the digital PO via the ISMS. Otherwise, the RPA bots will send the digital PO via email. Solution 2 will be enabled using 3 key technologies. Robotic process automation will help in automating PO creation and delivery, and machine learning spearheads the automated verification and validation process, which reduces human capital. Lastly, we integrated open APIs to encrypt and provide instant PO delivery to suppliers. This increases supplier safety and helps strengthen the canned foods ecosystem.
We will now analyze the impact and challenges of Solution 2. By hyper-automating the PO delivery process in canned foods, Solution 2 drastically reduces the total process time by 87.5%, which saves costs on non-value-added activities that are not essential to the value chain. It also allows us to entirely remove the role of PP, which helps to lower the cost of resources. There is also added encryption on PO data when suppliers turn to use our ISMS due to the common ecosystem with canned foods. This helps to increase total supplier count for canned foods in the long run, which saves costs from the wider network of suppliers that canned foods can tap into. However, we have also identified 2 key drawbacks from Solution 2. First, the ML model requires a large labeled sample data to train a functional model. Fortunately, this can be alleviated by tapping into canned foods' historical records of PR and PO to form initial train and test sets. Second, PB might be change resistant as they might feel uneasy with the lack of human intervention. This can be potentially mitigated through proper training of workers where we allow PB to thoroughly understand how hyper-automation will streamline the PR to PO process. With the use of hyper-automation technologies, The workflow allocation in canned foods business processes can be optimized with the assurance that repetitive tasks are completed constantly and efficiently. We are positive that canned foods possess the headroom for growth, and through implementation of the appropriate technologies, the company will chart its path towards being a leader of Industry 4.0. With that, thank you for your undivided attention.